Good morning. My name is Ken Fronheiser, and I would like to welcome you to Keystone Precision Solutions weekly webinar series. Today's webinar is called Driving Your Deliverables. Just a little bit about Keystone. For over 30 years, Keystone Precision Solutions has provided you with solutions you need to get the job done. We offer everything from training, seminars, rental, repairs, and education. We cover over 55 million people, covering 13 states from roughly the Washington, D.C. area, all the way north up into New England, into Maine. We are headquartered in Allentown, Pennsylvania, and we are well north of 40 employees. Our solutions cover everything from construction laser levels, mechanical transits, robotic total stations, GNSS systems, your simple basic hand tools, and your more advanced technologies, scanners, whether they are on or off the tripod. Our philosophy at Keystone Precision Solutions is to provide measurement solutions that increase our customers' productivity and profitability. We just don't want to be seen as someone that you come and buy something from. We want to be part of your business and part of your solution. With us today, we have two speakers. Justin Brooks from Trimble will be kicking off our webinar today, and then followed by that will be Jennifer from Topo. So with that, Justin Brooks, I'm going to pass it over to you.
All right, thanks, Ken. And I'll pull up my screen here. Can you guys see that okay?
Looks good.
Excellent. So hello, everyone. My name is Justin Brooks. I work on the mobile mapping team here at Trimble. My background is in mechanical engineering, and I actually spent some time working with the manufacturer for the lasers that we use on the Mx9 here. And then I also spent some time on the ground, actually utilizing these systems for production level projects for DOTs and various utilities. And now I work with Trimble, helping to increase the utilization of these systems across the board. And today I'm going to be giving a brief overview of the Trimble mobile mapping portfolio that we've now built out over the last couple of years. And then I will pass it over to Jen, where she will cover some of the ultimate deliverables essentially that we can pull out of some of these systems and how it might help your business.
Hey, Justin, real quick, this is Ken. If anybody has any questions during the presentation, please feel free to put them in the questions box and we will answer them as the presentation goes.
Thanks, Ken. All right there. And so here is our overview of the mobile mapping portfolio here at Trimble. On the low end, on the right-hand side, we have the MX7, which is our imagery only system, which is kind of going to help you create a Google Street Maps level type of imagery and allow you to kind of use that imagery to geolocate assets and kind of pull out information that may be useful. And we'll cover some use cases here in a moment. Then we have our new MX50, which is actually based on Trimble laser scanners. And it kind of serves as our mid-range LiDAR system that's still very dense and at a much more reasonable price point than some of our more advanced options here with the Mx9. And then ultimately we have the Mx9 itself, which has two of the Regal Vux1HA laser scanners, a couple different planar cameras, and also the Ladybug 5 camera up top. And essentially what you're going to get out of this is long range, high accuracy survey and engineering grade laser data that's going to help you essentially accomplish all your needs for various surveying engineering type projects. Now we can see here that the Mx9, for example, as I mentioned quickly, has both spherical and oblique imagery. It says here the range is up to 150 meters, but the Regal scanners can actually reach well beyond that. We just like to list 150 because that's kind of the usable range where you will be able to, identify assets and actually pull things from the data. But the Regal sensors themselves can actually reach outwards of 400 plus meters at their lowest scan rate. So note that you'll be able to pick up pretty much everything you need within line of sight. We have, trying to hide that window there. And as I mentioned, it works ideally for surveying engineering type applications, road and rail infrastructure, smart cities, utilities, construction and maintenance, you name it. The Mx9 can kind of fit any role. But it's also our premier system and it's quite costly to get started. So that's why we've also implemented our Mx50 here, which only has the spherical imagery, but it still has the dual laser scanners that are limited up to 80 meters, which we found for corridor mapping is still more than enough to kind of capture everything you may need. And now this system is more ideally suited for asset management type applications, municipalities, kind of utility work, road maintenance, and then of course, like some GIS capture data, it'll be more than accurate enough for all of your asset inspection and asset management applications as well. And then finally, again, on the Mx7 side, it's only imagery with the Ladybug 5 Plus, and it no LiDAR at all, but it can kind of help you create your Google Street Map, and it's great for road inspection, telco and fiber to home applications, that street level Google imagery. It's also been used quite a bit for disaster relief and all types of disaster management applications, and really just helps you create your own updated maps as much as possible. Essentially, you can get out and control that anytime that you need to. And to dive a little bit deeper into each of these systems and kind of cover some of their specifications, the Mx7 is just easy asset management for more frequent inspections. And now you can start to do these inspections from the safety of your vehicle. You could just kind of capture the project site while driving around. You no longer have to walk around, boots on the ground and take pictures and possibly put yourself in harm's way. So the safety factor associated with all these systems is, you can't quantify there. It's very helpful. It's definitely a much cheaper system to get started. And to note that, we have various applications here that I kind of already started to cover there. But this system has a GNSS antenna on top of the system for your position. Then it also has the built-in Ladybug 5 Plus camera, an IMU, or something essentially that's going to calculate your orientation and help you make accurate measurements from the photos themselves. And also everything is included in the system itself, such as the software and the storage. And then you can operate these systems from your own user device in the vehicle, such as even your phone or a tablet. You don't necessarily need the hardwire in a laptop, although that is certainly an option as well. And the system itself comes with the roof rack, so a solid mounting system that just mounts to essentially 2 parallel bars on the vehicle. And this is going to be common amongst all of our systems there. So you'll see this trend for the other 2 systems as well. We have the Mx7 itself. The options for a secondary GAMS antenna, which is essentially a second GNSS antenna that helps you calculate your heading, especially in GNSS outages, such as like dense cityscapes or canopy cover, or even through tunnels and things along those lines. We also have a DMI that'll help in those GNSS outages as well. That's going to track your distance traveled, and also, more importantly, provide you zero velocity updates, or essentially when the vehicle comes to a complete stop, it'll let the system know to prevent any additional drift or movement out of the GNSS and IMU. And then inside the vehicle itself, all of these systems we could run straight from the power of the vehicle. So while you can have a backup battery if desired, you certainly don't need one. And we have a power box essentially that's going to help smooth out the power and make it so you don't need any of those external power solutions. So again, while we could hook it up on anything from a boat to a side-by-side to a golf cart and things along those lines, utilizing some deep cycle marine batteries, most of our customers are just hardwiring it straight to the vehicle and essentially able to operate as long as they have enough storage. And everything is operated through Wi-Fi, as I mentioned. So you can tap into the system with just your phone or a tablet, but there is also a LAN connection as well. So we have a couple different options for different customers in various environments as needed. And I have a quick just little view here of some of the Mx7 data in like our publishing environment. And again, this is imagery only here, but you can see how you can kind of scroll around in the full 360 imagery. you can notice how we're able to extract various points and get the GPS location of those points. We could also annotate the data and make notes for our colleagues or our customers, and kind of pull anything out of the data that you may need during the collection. And the use itself is very intuitive. You kind of just scroll around with the scroll wheel on your mouse, or you can click ahead to the little panoramic bubbles. And this is just a really kind of easy user interface, kind of like a Google Maps, that will allow you to search through your project site and pull out anything you may need. And now jumping up a level to the Trimble MX50, which now implements our own laser scanners. So this is kind of like our practical mobile mapping system, combining imagery and LiDAR. And it's utilizing actually our LiDAR technology based on our X7, like terrestrial platform. So these scanners are very accurate and actually more precise, or less, point cloud noise than our high-end Mx9. We're just limited on that range, as I mentioned, and our density is roughly half that of the Regal scanners there. But this system incorporates the full field to finish workflow, where again, with our software suite we sell with the system, you'll be able to do everything from capturing in the field to processing the LiDAR data and the imagery, registering that down either to control or cloud to cloud to itself. And then at that point, usually our customers are kicking it out into something like Topodot, where you can then capture the information that you need more quickly and easily and deliver it as needed to your customers. So as I kind of mentioned briefly, these systems are more ideally suited for like highway asset management, even road monitoring, now that the laser scan is so tight and the data comes out so clean. The telecom industry has been using these quite a bit for the fiber to home, and definitely the asset management side. And even DOTs now have been interested for these digital as-builts and creating kind of these 3D digital twins, essentially, is a common term thrown around now, before, during, and after construction. So these systems are a bit cheaper, essentially, than the Mx9, so it's a lower barrier to entry, and also still gives you that high-quality professional data that your customers may be looking for. And our system overview here, just to dig into some of the specs. We have two of the Trimble laser profiles measuring about 480 kilohertz apiece, so right up near 1 million points per second total, and 240 line scans per second total. We have the spherical Ladybug 5 camera up top, and we actually have options now for both the Applanix AP20 IMU and the Applanix AP60 IMU, which is kind of like the lower end and then the highest end commercial IMUs on the market right now. And those will just essentially, the differences between the two is the low end will still capture very good data, especially in open sky. But that AP60 is really going to shine when you start to have your GNSS denied environments. It's going to hold your positional values much longer without any GNSS. So if that is important to you, you might want to consider the AP60. Otherwise, the AP20 is still good enough for survey grade work. You just might need to spend a little more time in the field laying down control, and or spending some more time with some dynamic driving and things along those lines to get the IMU down to spec. Again, this system here, which is a little different than the MX7 itself, but note that the roof rack, control unit, and the power unit for both the MX50 and the MX9 are exactly the same. So consider now that Keystone, for example, has their own system. So if you guys were to get an MX50, for example, in the long run, and you might want to rent an MX9 for some certain projects, all the accessory components are essentially swappable between both systems. So all you'll need to do is pop out the sensor head and pop in the new one, and you'll be able to utilize all the other equipment as needed. On the control unit itself, we have 2 x 2 terabyte hard drives, so a total of 4 terabytes, which is usually good enough for a few days of collection, but at least a full 8-hour day at the max scan rate and the max photo frequency. So you can ensure that you're collecting or that you have more than enough room for your data. And these drives are hot swappable as well. So you kind of just end your project, pop out the drives, pop in a new one, and then you can start the project right back up and continue scanning. And again, the power unit is really capable here, where it kind of has an inverter and a capacitor, where it's going to smooth out that power from the vehicle and put it in a way that the system can utilize. And I've never seen any power issues, knock on wood, with these systems so far. But I remember working with some other systems in the past. The power would always be finicky, especially with these new vehicles that have these smart alternators that tend to idle and stuff while we're at lights. This power unit smooths all that out, and we don't have any issues on the power side. And note that we have this one main umbilical you can kind of see here on the sensor unit, this umbilical cable that will kind of reach inside the vehicle, and that'll handle all power and communications that are needed. So it's a very clean interface, where some of our systems in the past, had a whole server rack in the back seat that you had to set up and took basically a week to get everything together. Now I can typically train people up on this system within a few hours, if not a single afternoon. So it's the ease of use has definitely come a long way with these types of systems here. And again, similar to the Mx7, it has the same kind of interface in the field called Trimble Mobile Imaging that you could operate from your own tablet or phone, for example. But of course, if you'd like to hardwire in, some people, for example, will keep the control unit and power unit and stuff in the back of a pickup truck, for example. You could always then hardwire in with a laptop if need be. And here's again just a quick example of some MX50 data here in Trimble Business Center. And Trimble Business Center is kind of like our one-stop shop for LiDAR processing, image processing, registration, again, either down to control or cloud to cloud. Both of those are very important to ensure that you're getting, a kind of unanimous, homogeneous point cloud that you could then use to extract information from, which Jen will talk about more here in a minute. But in TBC, you also have a lot of QA/QC tools like we see here, taking very tight cross sections, checking the quality of your control and how well your control fits to the LiDAR data. Of course, force fitting it if need be. Even going as far as to colorize the data with the 360 camera if need be. And then we also have options for classification and things like that as well. Although, as I said, most of our customers are kind of just getting to the point where they have a very clean point cloud and then kind of kicking it out into Topo. But you can see here, you can make some very quick measurements with the point cloud data there, and we're getting, vertical offsets less than a centimeter in this case. So this data is very clean, very sharp, and gives you a lot of context for your project site and allows you to make better decisions, essentially faster. And finally, we'll have our premier Mx9 system. This is our high-end unit, and we have a recent update to these systems now, implementing Regal's new VUX1 HA scanners. They used to only be 1 million points per second per scanner, but now we're getting 1.8 million points per second for a total of 3.6 million points per second on the ground. That is an incredible amount of data and density. So that allows us to travel even at highway speeds, for example, and still capture more than enough information. Even going 70 plus miles an hour, you'll be able to see things like mile markers and stuff still on the side of the road. We also have implemented now these new 12 megapixel cameras, which will allow us to kind of pick up better details, such as like reading signs or even the pole tags on power poles, various asset management inspection, options now with the 12 megapixel cameras, when before we just had 5 megapixels, which was still more than enough for identifying things in your environment, but sometimes would get blurry as you zoomed in. So these new cameras, I'm really excited to announce, are going to be much sharper, and you're going to be able to pull much more detail out of that now. We're also implementing our independent camera trigger as well, so you could actually operate the Ladybug 5 Plus spherical camera up top at a different frequency than your planar cameras. And that could be important, for example, if you need more coverage with one or the other, and you're also trying to maintain, data management. This does become a lot of information at some point, and you have to figure out how to manage terabytes and terabytes of data. So having that independent camera trigger, I think, is going to be well received and utilized quite a bit in the future now. And of course, the system can now use our newest version of TMI and TBC itself, which again has just enhanced the efficiencies, sped up processing time, made some of the old tasks like registration and stuff much faster and easier for the end user. And again, something that used to take me well over a week to properly train somebody on, now I can train up in a single day, and we could spend a few days kind of collecting data and actually getting hands on the system. So even as the operator and trainer myself, it makes it much easier to kind of to pass down the information to others, and to, if there's a high turnover rate with operators in the field, all this stuff is just extremely easy to use. And where in the historically it took quite a bit of know-how to get these systems to operate at their peak efficiencies, to get that survey grade data. Also, a new thing that we added here at the bottom is just a new 4 terabyte disk for the Mx9. So as the MX50 had 2 times 2 terabyte hard drives for a total of 4, now we could have up to 8 with the Mx9. And again, that's just for the higher data rate. It'll allow us to capture at a full 8 hours at the max scan rate, max photo frequency if need be. But those drives are still swappable quickly and easily. And as I mentioned there quickly, TMI field software, independent camera trigger, newest firmware updates for both the MX50 and the MX9. And we also actually boosted our Wi-Fi firmware as well, where some of our users were having some Wi-Fi connectivity issues. This new firmware update has been excellent so far, and we haven't had any such problems. And also our team is really responsive to this kind of stuff too. I do want to highlight how, compared to some of the other manufacturers out there, Trimble has multiple lines of support, whether it's, our partners and guys at Keystone, or it's kind of like your first line of support. You'll have my small team for the mobile mapping side at Trimble itself. And then of course we have our whole Trimble support team. And this kind of multiple layers of support will mitigate your downtime, ensure that always someone will be there to, pick up the phone or answer your questions if you ever have any issues. So I think that's really a really powerful tool in itself, the fact that you'll always have somebody on call. And of course, Trimble Business Center, the new release was 5.70. If you guys currently use TBC in any of your other workflows, the mobile mapping tab, essentially, it's just another tool set within TBC, will fit seamlessly into your workflow. And then you can start to utilize all of this LiDAR data and imagery with all of your other information that you might be capturing in TBC as well. So I like how it's kind of brought everything together and consolidated all of these different data types into one place. Again, we have enhanced mission registration, image blurring, things like that now we could start to, adhere to privacy issues both here in the States and worldwide. So now we're starting to take these steps forward to, again, kind of make it closer to a deliverable than ever before. But still, I think you're going to be impressed with some of the things that Jen has to show off here shortly as well. And then we'll go into the applications themselves. Again, road and rail construction is a big one, working with a lot of DOTs and contractors to kind of make sure that we're building the safest roads we can, essentially, while keeping our operators safe as well, and just giving way more context than we've historically been able to provide. Essentially working from 2D maps, a lot of times our customers are still taking this really sophisticated 3D data and still creating 2D maps from them. So having this type of data available, I think, is helping push the industry forward, and certainly going to only give us better information in the future to make better decisions. And this also applies to the rail environment as well, tunnel and bridge infrastructure, of course, cities and urban area development. The digital twin thing I mentioned earlier is a key phrase thrown around quite a bit, where essentially you just drive now through the city and you'll have a direct representation, in a digital environment of the real world, which is quite nice. And also a unique application down in Central and South America is the taxation portion as well, where, again, before and after disasters, or even just mapping out current infrastructure, and even knowing how these local city governments can even implement their various taxation methods, which is interesting. And it's going to be similar here. Again, we have the same roof rack, the same options for GAMS and DMI. We do have, power from the vehicle, and I recommend a secondary car battery for the MX9, just with this added power now with this new unit. But again, we've operated it cleanly without that secondary battery as well. So keep that in mind, that power unit still does its job. And while a lot of our users have a secondary backup, just so it doesn't drain essentially the main car battery, that a single battery is still fine. Also, again, even for this high-powered equipment, if you have if you want to set up on a golf cart or side by side or a small boat, for example. Usually just setting up two deep cycle marine batteries in parallel does the trick as well. And you usually get about 3 to 4 hours per battery, obviously depending on your scan rate and photo frequency. So again, these systems are versatile. We certainly don't force you to buy a Trimble battery or anything along those lines, but we have a few different options there to control and power the unit. And of course, we include all the cables needed. And we do not, essentially, a tablet does not come with the system, but you could use anything that connects to Wi-Fi that you may have currently available. So that makes it very quick and easy. Even, for example, God forbid, you're in the middle of a project and your laptop goes down or something terrible along those lines. You don't lose any data. No data is actually stored on the laptop or the user device. You could just pop it open on your phone, finish the project cleanly in the right way, so there's no critical errors or anything, and then continue on. So I really like that added versatility and resilience kind of that we've implemented into some of our systems. And here's just some example of Mx9 Point Cloud. And if you take it from the certain angles, it looks essentially like a photo. The data is so dense now, and once you colorize it with that ladybug camera up top, I mean, essentially you're getting a photorealistic point cloud that allows you to then design, build, extract, and model from. So the data itself is quite incredible. And if you guys are ever interested, we have various links that we can provide for sample data. And of course, we'd love to hop on a webinar with you and give you a full demonstration of the workflow, show you how easy it is if you need be. And just in general, before I pass it off to Jen here, wanted to outline the full Trimble MX workflow, and this applies to the MX7, MX50, and MX9. Of course, we'll spend time capturing in the field with TMI or Trimble Mobile Imaging. We will process everything in TBC, and again, that goes everything from scan generation or image generation to registering down to control or cloud to cloud. Classification, here we could see that TBC has the ability to classify out things such as ground and vegetation very quickly and easily without much input from the operator. And then of course, the extraction side, Jen will cover here in a moment. And also sharing that data is incredibly important as well, which Jen might touch on. We have various ways that we could kind of take all of this information and billions of points and simplify it down essentially to a single link, where then either you could share the data internally or share the data with your customer. It becomes a very valuable tool to then be able to kind of publish and share this data very easily without having to ship around hard drives with terabytes of data on it. So Jen, if you're ready, I will at this point pass it over to you and allow you to dig into some of the extraction and sharing side there.
Thank
Awesome.
you, Justin. All right, let me go ahead and show my screen.
Okay, Jennifer, I should have just made you the presenter.
All right, let me make sure you're seeing my the right screen. Are you seeing the top of that screen then?
Yep, I see a Topo dot with a railway.
Perfect. All right. So thank you, Justin, for that great introduction. I'm gonna quickly introduce Topo dot to you all and just kind of tell you a little bit about who we are and what we do. Again, my name is Jennifer Triana. I'm the Business Development Director here at Topo dot. I've been with the company from the very beginning, and I'm not alone. I have a team here in Orlando, Florida. This is our headquarters, and we have been in the LiDAR industry for quite a while. In half of that time, basically developing software. So our background is from the equipment itself, from the understanding the LiDAR itself, and then developing tools for applications in the transportation industry. So here's our team, and really the majority of our team is dedicated to support our customers and make sure that you guys have the best tools for any applications that you might have. We are worldwide, so we have offices in other places in the world, and we have about 6,000 users all over the world, pretty much catering to the transportation market. And so at least 30 DOTs in the States use Topo dot and also create a lot of work for us because a lot of the people providing these kind of deliverables to these states also require Topo that. But we also cater to other applications like telecommunications, utilities. There is a broad spectrum of applications that you could use point clouds for. So in essence, that's who we are. I'm gonna go ahead and hide my camera so there's a little bit more bandwidth for the video. There you are. And because I'm gonna show you a couple of videos here. And first, I just kind of want to introduce TopoDot. So what is TopoDot? TopoDot is a high performance microstation application for importing these point cloud information and imagery that you're getting from these mobile systems or any kind of system that collects a point cloud and turns it into a topography model. It is a microstation based software or it requires the microstation platform or any Bentley platform. But we can extract from all this point cloud information 2D models, 3D models, asset inventories, 3D structures, indoor, outdoors, you name it. Anything that you have a point cloud for, you can pretty much use TopoDot for that modeling. Lately, we've been focusing a little bit more into the data analysis side of things. So instead of modeling it, basically using the data or the point cloud information to do more analysis of the data itself and create reports. So I'll talk about that in a little bit. I just kind of wanted to explain a little bit about the process that Justin touched on in his last slide on what is the process and how do we go about basically our synergy between the Trimble systems and TopoDot. And so you have this area in red here at the beginning where you acquire the data, collect the data, and there is that system level processing. Basically, all the aligning of the point cloud and that registration to your control point will happen within TBC or whatever software comes with your scanner. And they know better about how the system behaves than anybody else. Once the data is aligned, it's ready to be processed, you don't really need to do anything else to the data. You don't have to clean it up, merge it, classify it, do anything else. Just export it, and then you will be able to bring it into TopoDot. And within TopoDot, we will help you manage your project despite of size. It could be, a couple of scan positions, or it could be miles of data. And we'll help you manage it and check it for control, for quality. So our assessment tools will help you evaluate whether the data is good for your project requirements. And if it's not, if it's missing something, maybe you need to introduce more control or realign something, you can go back to the system level processing. We won't move the data, and you don't want somebody that is actually doing the processing, the feature extraction, to move data that has been registered to survey control, right? And then the larger part of the process is the feature extraction. And our philosophy has always focused on making tools that will cater to your needs to extract the most accurately but in automatic way. So we have that combination of not just making everything automatic and not knowing where it made a mistake, whereas instead we just create tools that have a little bit more user input, where you have a lot more control, and then as fast as possible. There is something that is very unique to mobile systems, and that it's not applicable to anything else. No other terrestrial or UAV system has right now, is that with the mobile systems you have that trajectory information. So how is the system behaving, or where is it moving? That information is part of the metadata. And if, for example, you need to accelerate schedules, so you have a project for the state and they are providing you with control points, but the data, those control points are not ready, yet, but you have your system and you're ready to scan, you can go ahead and scan and get a relative position and start extracting. So do the feature extraction portion. When the control comes, you can reproject that line work, that point cloud. And with that new projection, you can reproject the model or the line work. So again, this is very unique to mobile systems, especially if you collect images or calibrated images with your system, so Mx9, to be able to accelerate the schedules between, aligning to control and the feature extraction. And again, this is kind of rare, but it is possible. We also give you a quality control spot or step at the end of your process. That way, your model matches your point cloud. And we've already checked that the point cloud matches the control. So there is that lineage to the control, to the initial control, all the way through. And then at the end, you can export this information wherever it needs to go. So if you're in a microstation environment or deliverable, you can just, turn it in. Or if you need to go to Civil 3D, ArcGIS, wherever you need to go, what we are extracting is simple line work that can be exported in any other format. So having said that, let me just kind of show you some examples. And I'm not sure how these videos are playing, but they're not that fast. So I hope I can talk over them without any delay. But in this video, I just kind of want to point out that Topo is a great platform to combine data. So today we're working or we're talking about mobile data, but maybe you have a site where you require multiple systems. Maybe you require, in this case, for example, the mobile system collected the rail portion, and a UAV system or a drone system collected the top of the hill area. And this data is combined into the same platform to be modeled as one. As long as the data or the systems are using the same datum, your data can be combined, and it it doesn't matter what system you're using as long as it's a point cloud. So it is very versatile in that regard. And so the tools that you're learning for mobile scanning will apply to drone data, will apply with static data. So it's only one set of tools that you really need to know this for whatever system you're applying it for. We have tools for almost every application in, again, the transportation and construction applications. I have examples for a few of these, but if you have any questions about any particular project where that you might be thinking of using point clouds for, let us know. There might be already a solution, and if not, we are software developers, so we definitely love input from our users and our customers to develop better tools. Today, I'll focus a little bit more on the topography extraction, and maybe I'll show you some tools for pavement applications too, depending on our time. All right. So in this quick video, I want to show you a project with the Trimble Mx9. We can use Trimble Mx50 data too, but this is kind of like the best data that there is out there. So it is definitely a pleasure to work with this data. Here is Topo Share. This is our application for sharing project information. So we're not hosting your data. You have a data host, but you store all the project information through Toposhare. And Toposhare is going to allow you to share this information quickly between users and be able to download this data quickly from the web without, again, shipping hardware. Now, here is an example of the assessment tools. Here's one example of the deviation analysis. So you see the red areas showing areas where there is misalignment between multiple passes. And this is rare, but it might happen. And all you need to know is just to be aware of where it's happening and what to do about it, right? Sometimes all you need to know is, okay, this is 5% of my project, not a big deal. But if it's 20% of your project, maybe you have to go back and figure out if you need to add more control or whatnot. But this kind of reporting will give you confidence on your data, and you know, if you do it before your feature extraction, then there are no surprises during your feature extraction. Because if you have to move the data, the line work might not move at the same in the same way. In addition to the point cloud, you can bring imagery. So these are the calibrated cameras that are mounted on top of the scanner on the system that are calibrated to the data, and because they are calibrated to the data, not only you can see them against the point cloud, but you can also really use them to do feature extraction. So you can actually map on the image if you do want it to do that. So here what we're showing is how tightly it is mapping the point cloud over that sign area, the sign that you see on the point cloud. And when it's tight like that, then you can definitely use the image to do the feature extraction. So now here's the example of of feature extraction. So we start by creating an alignment down the road, and it is a very easy process if you have paint stripes or painted lines, because we can isolate the information of the paint stripes since it's highly reflective. And we use that reflectivity information to automatically pull those lines out. And you can see them happening on the image. Those blue lines that you see there are now vectors, are now actual CAD lines, CAD elements. We do the same similar process with the breakdown extraction. So in this case, this is the automated feature breakdown extraction called the template tools. So we just basically create a template for a curve or barrier or whatever kind of break that you're trying to extract, and allow it to travel in certain direction and try to match it. It's a little bit smarter than just matching the template, because in reality you have all kinds of changes in elevation, you have changes in slope. So the tool will cater to that, and it'll give you options for you to qualify the process or make changes as well. Here's another process for breakline extraction. It's called the Drape to data tool. And this will be useful in areas where you have a shallow break, like paint stripe, like a sidewalk or edge of shoulder or something like that is against vegetation. This tool will actually look only at the concrete side and not involve the vegetation at all. And because of that, you never have to clean up your data. We in Topo avoid trying to clean up vegetation, people, cars, any kind of noise, because that takes a lot of time, and at the end of the process you still only have a point cloud. Whereas instead we just ignore noise, and with that you save a lot of time in your processing time. So here what we did was extract additional points in between our breaks to give a DTM or a TIN file more definition in between your break lines. So you can see actual terrain slopes or changes in terrain for the road and for the vegetated areas. Now, if you have a site that might not be in the best state, right? Maybe you need to have a little bit more control over your breakline extraction because you have dirt, you have leaves, you have water, you might have changing break lines, constantly changing break lines. You have options that are semi-automatic, meaning that you have more control over, in this case, the breakline extraction tool allows you to see cross-section by cross-section. You see how it is extracting top of curve, back of curve, flow line in the image as well as in the top view, and you can make adjustments even if it doesn't happen on the data. So for example, if you have grass growing over a certain area, but you know where your back curve is or you know where your flow line is, you can make that decision even if it's not on the point cloud, similar to what you would do in the field, right? You'll also have plenty of features that happen in between your breaks. You have ramps, driveways, inlets, all kinds of features of this nature. Now, if you try to extract break lines automatically, and you can say, I want a break line every 5 feet. It's a lot of nodes, but not where you need them. Instead, here we focus on the areas that are important. In this case, we created the break lines around this ramp area. And then for the ramp, we do something called a smart cell. And the smart cell is a template for the ramp that it's already have all the line work in the proper levels, and all we have to do is adjust it to the current conditions. And again, you can use the image or you can use the point cloud if you have the definition or the resolution on the data to do that. And you have, to all of these processes, is not showing in this video, but to all of these processes, you have a QA/QC portion to it. So even though there is an automatic function that, like, let's say it snaps to the data or drapes to the data, you will be able to create cross sections and verify that it is indeed at the right elevation. Maybe you need to do asset management or collect assets on your topography. We have a few tools. We have, well, actually, there were two tools that got combined recently into one. And there is an automatic tool that will collect anything vertical, any vertical asset automatically. So it's not what is showing here. This is the more manual version of it. But it will actually pick up anything that sticks up from the ground. So pole, fire hydrant, light pole, tree, etc. And all you have to do is basically verify that it is labeling it properly, and that's it. You can do the same with flat assets and like manhole covers or utility covers, etc. So at this point, I have a few more videos. How we doing with time? Okay. All right. So let me just go ahead and jump on another application.
Hey, Jen, while you're
yes.
switching there, we did have a quick question concerning extracting some concrete footings from a point cloud. So maybe this would be more on the terrestrial side. But is there anything that your software offers to be able to quickly extract concrete footings?
Yes. I'm gonna show a video at the end of this presentation to show that exactly. So bear with me just a few more videos, and then I will pop up video for that because it's in another platform. It's on the Prezi, but I'll definitely touch base on that. No problem. I just kind of want to expand a little bit on the asset identification because I know this is something that you might want to use, your Mx50 system for. Now, if you don't have the images, if you don't have the camera, you can still do all of these processes with just the point cloud alone. The essence of the software or our main input is going to be the point cloud. The images are great. It are going to be very beneficial for identifying types of assets, maybe what the asset says or what's the text on the asset, but it's not necessary to be able to identify it. Now, our tools will automatically pick up elevation, ground, height, tilt, diameter. You will be able to measure, assign. And this tool has it's got artificial intelligence to identify or learn the patterns of the assets that you've identified. So if you see that these are light poles or utility poles, it will remember that and it will keep labeling them or switching back to the proper label or feature code based on the shape or based on the geometry of the asset. Now you can also attach all kinds of attributes to this information. So if you don't really care so much about the graphical information, or maybe you want to add to the graphical information like an inventory, right? A Excel file with all this content, all this information that you extracted from these assets, you can actually attach that information to your asset extraction and export it as ASCII or for ArcGIS. Another application that is very that has that has taken off pretty much. It's all of these utility pole identification and labeling, along with power line extraction. So this is another Mx9 project that we demoed, and it's basically the process of the utility mapping, the utility pole mapping. So with our utility pole mapping, basically we would start actually at the power line extraction, and in the power line extraction we will create a list of all of our poles. And then once you have a list of the poles, then you can go in and identify additional information about the poles individually as needed. Now this is being a very this application has been taken off because it's a very safe way of assessing this information, collecting this information, because you can collect it from the field with the mobile scanner, and all of the measurements can be done directly on the software. So you don't really need to be out there in collecting dimensions with a pole or a rod. One other application that is also kind of new and that is being quite popular lately is the pavement condition analysis. We call it road surface analysis, but it's pretty much for PCI analysis. And it's a very quick assessment of deformation on pavement on any road surface. And it's just basically we collect the paint stripes to delineate the lane lines, and in between those lane lines we can evaluate where is deformation, large deformation, and basically label it and add a degree of deformation based on ASTM standards or whatever standard you want to use or whatever measurements you want to use. So these will automatically detect the type of distress, whether that's shoving, rotting, potholes, etc., the degree of deformation, and it will create a report to the PCI report that can determine the health of any particular road. So this kind of process has always been a process that is for dedicated systems, pavement systems that are quite expensive and like a black box, not a lot of information of how it was collected. But now with this geospatial systems, you can create this sort of analysis without much work, without much with very specialized tools or whatnot. So all of these processes, all of these tools are part of Topo. You buy one product, you get everything, and there is a ton more. So volume calculation, clearances, clash detection, just name it. You can find some more. And so because we had that question, I'm gonna go ahead and pull up the Prezi and kind of show you some of those footings. Let's see if I can pull that up. Let's see. All right. So if you guys want, we can add with the webinar a link to this Prezi, so you can explore a little bit more the videos and other features that we have. And let me see if I can find here a utilities. I'm not sure if I have a utilities one, but because I can do that footings on a substation, but I can show you a little bit more of that in this example, I think. So it'll be a similar process to this. It's just basically, it's all about creating cross sections. It's about identifying the cross section in which you can see those footings, you can automatically create the edges of your footings, whatever shape they are, if they are square or rectangular, even faster. In this case, the shape of the building is a little bit odd. And then you can adjust it to the ground, or you can drape it down to the ground. And so the draping function will allow you to get the actual vertical elevation of that feature. So this is just the 3D model. I'm going to go ahead and go to the next video that actually shows the footing draped to the ground. So very similar situation. You just take a cross section from front view, cross section from side view at the elevation of your choice. Obviously, you need to be able to see the data a little bit. So if this is a substation or something like that, you can scan from outside the substation and still get plenty of data, plenty of information to collect those footing. And then draping the elements is it's what's important. Oh, I think this just creates a 3D building. Sorry for that. I meant to show you the draping. All right. It'll be a similar situation for the draping. Let me see if I can drape it. Yeah, so it'll be similar, but I don't have video here, my bad. So so if you have an application where that I can't show you more about here, please reach out to me because I can show you on your own data what's possible. Okay, so we do demonstrations on your own data for your own projects. So if you have any questions, please let us know. And we'll also help you manage your information the best way possible so that you don't have to have a, gigabytes of data, of drives all around. Just basically be able to store it over on the web on the storage option of your choice, and be able to collaborate with your clients, with your partners, and be able to deliver all of this line work, all of these models from the point cloud the easiest way possible. And that is called Toposhare. So again, please let me know if you have any questions. Toposhare has a dashboard application that is web-based, where you can see your pictures, we see your data, we see your line work, and nobody has to install anything. So this is the best way to collaborate with your clients and partners and share the information of your project without having to get everybody trained on how to use a point cloud per se, or download any kind of software. And I think managers, engineers, designers love these tools because, again, they don't have to deal with the point clouds. You as a geospatial specialist will know how to handle the point cloud, will know how to survey from the point cloud, but the engineers or the PMs that don't really need to do that. They just want to know what's out there, how to extract from these data, and how to better use this data. So this is another kind of service that we provide along with Topodot to ensure that all of this information that you're collecting that is so rich will be exploited, or it's got, you can use the maximum value of your data. So again, we have a ton of tools, a lot of applications that you can leverage this information for, and we work closely with Trimble to ensure that anything that you collect with Trimble system can come in through into Topodot, if it's a point cloud, of course, and be able to extract and model from it. So I'll leave you with my information so that if you need to contact me, you will be able to. All right, and that's it for me. Are there any other questions, guys?
Hey, Jen, that's a great presentation. That was just the one question that we had, and since we are up against the time there, I think if anybody has any questions, please feel free to reach out to Jennifer, or you can also reach out to myself or Keystone. My email address is kfronheiser@keypre.com, or simply email sales@keypre.com, and we will be able to answer any questions or further the conversation. Justin and Jennifer, I'd like to thank you for your time today. Attendees, I'd also like to thank you for your time as well. Please be on the lookout for an email coming in the next week or so concerning our August webinar, which will be coming out shortly. So I hope everyone has a great day, and I look forward to talking to everyone soon.
Thank you. Thank you for having me.
Thank you.